Oh, there's fishermen. Alright, give me a second here, guys. I'm setting stuff up. We're gonna talk through some stuff. Let me pull up one of my... What kind of talk do we want to do today? We can go through the why engineering talk. I said I'd pull that up and stream that one of these days, didn't I? So you guys could kind of hear a little bit about what I was talking about the other day in our presentation. This was from this wasn't recorded for the ProLUG. We had a big event weekend about a week ago. So, all right. Also, guys, I had the day off today, but I got called into a P1 severity, which is like the highest severity for the one organization I used to work with. So they called me back in to work on some stuff, one of the colleges that I was doing some professional work for. So kind of smoked. But yeah, we'll go through this again for some of you guys that missed it or people that want to talk about. How's it going, Morrison? How's it going? Hopefully this stuff's useful. I just realized I had to get on. I haven't been streaming as much, and I was out of town. I was up in Colorado for Thursday night through Monday morning today, going and doing, I was training Brazilian Jiu-Jitsu all weekend, which is funny because it's actually called a wrestling camp. So I didn't call it a wrestling camp, but I almost always just say wrestling so people don't get confused and think I do karate, like our little penguins in our Twitch. All right. Anyway, so let's look about this a little bit. I'm just going to show you guys. This is my talk from the thing. I said I'd stream it one of these days. Oh, nice, Morrison. Are you going to go do some systems engineering? What are you working towards there? If you don't mind me asking. All right, guys. Let's we'll go through this and I'll talk about that stuff and hopefully some of this stuff will be useful to you guys. So a little about me. I'm a guy that does engineering for fun and profit. I've worked on over 100,000 Linux systems in the industry, and some of them actually have worked when I was done with them. I've worked building and engineering roles from passive to active security roles. I've done kind of a lot of things over 20 plus years. I've taught over 5,000 engineers at the college level. I don't include any of you in that. So, when I say over 5,000 engineers, I don't include like the professional Linux users group in that. That's more like just us hanging out and maybe a little bit of mentoring or whatever. But I've sat in over 350 technical interviews now as an interviewer. That kind of is a thing that people like to sometimes ask, like what kind of technical things I like to look for and that kind of stuff. And I have presentations on that if you guys want to see that as well. I run ProLUG with 2,300 plus members. We're always trying to get bigger. So if any of you guys want to join, you're always welcome to come hang out in there. Let me see if I can link that. There's our Discord on the Twitch side. And then maybe I can post it through. Hold on. There it is over on the YouTube side, the Discord link. Yeah, it didn't come through right, but the link's fine. All right, so let's talk about this a little bit. And I have a book, right? The book's on Lean Pub, and you guys can go look that up if you want. All right, so why engineering, right? Every page of this, every one of these at the top asks the question, why engineering, right? And one of the reasons why we're engineers and why engineering is because science explains the way the world works, right? There's making an observation, asking a question, forming a hypothesis, make a prediction, test that prediction, right? What we call testing the hypothesis. And then as you get into, if you go and do, if you ever work in a research-based role, we also form not just a hypothesis, but we form a null hypothesis. And then a lot of times we just reject the null hypothesis, and that helps us because you can't always say things are true. So sometimes we just reject the null hypothesis, and then that leaves us with what's left over, right? And then you iterate. You just keep spinning through to find more of these things. Make an observation, ask a question, form a hypothesis. By the way, this is the basis of what we call chaos engineering. You've got a system up and running. You've got a network, right? Over here, we're in my little werewolf system, and I say wwctl nodes list or whatever, and I see all these systems, and I say, well, what if I just go kick one of those nodes over? Does it come back up? Actually, we know right now that my system's kind of busted because for some reason, the servers, if I go to xcpng, by the way, I'm like cleaning up my system. I just got home today, so I haven't even logged into any of my stuff, right? I'm still getting back into my system for the day. If I go to XCPNG, come on, connect. What's going on here? You guys are embarrassing me in front of my friends. I'm just kidding. All right. Let's connect all of our servers real quick. Hold on. So these are my XCPNG nodes, right? Lord Processor, how would you go about studying for systems engineering if you were to start again in 2024, and what projects and tools would you focus on? If possible, open source tools. Thank you. Lord Processor, I would start with Linux, right? Like for me, everything goes back to Linux. The tool that I would use to do Linux, to learn Linux, like, all right, let me tell you guys, I'm going to tell you guys something real quick about when I started this, and I jokingly say this, but it's true. When I started this, what they would do is somebody would just toss you a Linux CD, and if you couldn't install that CD, yeah, it was still back on CDs back then. There weren't DVDs really going into computers back then. And you would just have to install it. And if you couldn't install it, you couldn't learn Linux. That was the end of the game for you. That was don't pass go, don't become a sysadmin. But nowadays, because you can just come here and you can go to, again, my labs or anybody's labs on Killer Code. I don't care whose labs you go to. My labs happen to be the ones that I go through the most. We got our Linux labs and our Ansible labs. This is what I would do. I would go and I would start learning Linux. Maybe from me, maybe from somebody else. There's other people that teach you Linux on Killer Coda. There's this Powell guy, Piwaz, and then I think there's a few other ones that you can just type Linux in here and find them, right? So where I'm going with that is that would be the first thing that I would start doing if I wanted to learn systems engineering. And then I would find like a group. I have a talk on this where I talk about like getting into the systems engineering world, like find a group of people that are also doing that and then go kind of hang out with them, sit with the engineers, see how the engineers talk, see what they read, see what they talk about, and then one day you're going to find out that you sound just like them and you understand the same things that they understand, that kind of stuff. Subdoy said, I'm studying software engineering, want to transition to Linux systems, a lot more interested in it as a hobby. Yeah, that's actually, it's funny you say that over on the YouTube side. Walnut said, study in and want to get into Linux as a hobby. Our group is hobbyists, right? Our 2,300 engineers are hobbyists. However, my goal with the group is to take the people that are hobbyists that want to become professionals and become professional Linux engineers. Hold on, Morrison, you said, does anyone know an open source alternative to Cameo? Unfortunately, I don't. I don't even know what Cameo is for architecture, design, and modeling, especially in context system and large scale. I've never played with Cameo. Hold on. What's this Cameo open source? Cameo systems modeler, huh? I've never played with it. I don't even know. What's their license? I always check licenses, guys. What's the license? What can we do with this that we're allowed to do? It's under an Apache version 2, meaning you can use it, but it's as is, meaning there's no warranties of any kind, right? That's fair. All right. I've never used Cameo, so I don't know any alternatives to it, unfortunately. Although I like drawing in Excalidraw, but I don't think that's going to help with all the modeling. Sys models from XML. So I imagine this pulls things in. Uses some Eclipse. Yeah, I don't know anything about it, unfortunately, so I couldn't give you a good answer for that. But to the question about doing Linux, or where you would start, if I was studying systems engineering and I kind of like knew things, but I had to relearn it. And hello to you from the Netherlands with the @YouTube. It's kind of an interesting name. I don't know if that's just like a thing that people can do where they can just say @you. Anyways, but yep, welcome. Hopefully this stuff's useful to you. The question was, what would I do if I was starting over? And I would first get into a tool that was free, which is like Killer Coda. I would find engineers and people that are doing this stuff that are interested in doing this, and I would join them, right? Our Discord is a bunch of super serious people doing stuff like this, right? And then down in here, there's talk about like where you would start. We've got our like our beginners start here, and you come in here, and here's if you've got nothing on a resume, you've got 0 things on your resume total, then you can go and start putting these things, go and learn these things and pass these things. And these are all certs right here. Every one of these is a certification that's free to study and free to take. Yeah, we're super serious. Yeah. So again, like you start from a blank page, and it's hard to get hired. It's hard to get into the industry, but you start to put things down that show that you're interested in working in this way and getting into these kind of things. So yeah, okay. I hope this stuff's useful to you guys. This is the goal of this, right? But again, this talk that I'm doing here is called Why Engineering. Why do we want to get into engineering? But engineering puts all this into repeatable practice. I tell people all the time, like, science and scientists, like, the reason I'm not a scientist, the reason I'm an engineer is actually from the next page. I believe it's actually on the next page, but it's like, hold on. So why engineering? Again, you do these things in science, but we turn them into real world things through engineering. And we specifically build engines, and engines are things that cycle. But let's get to why engineering, because it's not being a doctor. Ooh, brother. What is that? You don't have to look at stuff that's weird if you're an engineer. It's not being a lawyer. You don't have to know a whole bunch of stuff. Right? That kind of stuff. So why engineering? Well, maybe because we didn't want to do those things. I think I told you guys this before. In high school, I thought I was going to be a doctor. I did all the med science class. I did all the nursing classes that I could do in school. And nothing got to me. Guys, there was nothing that bothered me until I saw a chest crack. And if you don't know what a chest crack is, do not look it up. It'll make you want to not be in medicine. But anyways, nothing bothered me in all of medicine. But then I went in the infantry, and I couldn't have been a doctor anyways. Plus, I'm colorblind, so there's that. Yeah, chest cracks, they open a person up like a crustacean. It's to get at their heart. And in an emergency situation, it's pretty bad. All right, so this is another question. Again, why engineering? Like, why do we want to be engineers? I don't care what type of engineer we're talking about here. I purposely made this discussion to not be about systems engineering. It's just engineering in general. You could go work on refrigeration systems. They're still engines of some type. So let's look at this. So businesses run on repeatable, accurate processes. That's my own quote, but that's true. That's just the truth of life. Businesses want to use our systems to build repeatable, accurate processes. That's why they use computers. Before computers, you know what they did? They used paper and big big filing cabinets and rolling filing cabinets. Anybody here ever been in one of those? Back in the day, I remember my medical records in the Army were kept in. They could like roll these filing cabinets around, and they had all this space in the back. But they could you could basically like collapse the library in on itself and only have the one set of like shelves that you were looking in. It's actually really interesting. But yeah, if you can't describe everything you do as a process, you don't know what you're doing. So you got to be able to break things down into individual processes, guys. That's a big part of it. If it can be measured, it can be improved. That was Peter Drucker, who was a real big business tycoon here in America. Edwards Deming was a guy who, after World War II, went and helped do a lot of process management work over in Japan. He's a big reason why they're an industrial powerhouse like they are, him and his processes. And you can go look up the Deming principles, and you can go look up TQM, Total Quality Management, and Six Sigma, and all of those things completely go off of a lot of his. There's other people that are involved. There's all kinds of other people that are involved, but Deming is kind of one of the big people that's studied about. There's Lewin's model of how we do change for change management. There's a whole bunch of them, right? But I mean, none of you probably are interested in going deep into that. But if you are, message me on Discord and I'll talk to you about it, because I can talk at length at that kind of stuff. I have a master's degree in that. Actually, I have 2 master's degrees that directly deal with that. But that's neither here nor there. So why engineering? Okay, because with engineering, we build engines. We build systems that cycle. This thing on the left is just some cycle. Who even knows what it is? Somebody could probably figure it out. You probably even throw that in the old Googles and it would tell you. But there's something, and we have to feed it, and then it chambers, and it locks, and it fires, and it unlocks, and it extracts, and it ejects, and it cocks. And it has to do those 8 things, and it has to do them in order. And if it does them in any other order, things are not going to work right. And it can't do like step. This is a big fucking annoyance of mine. It can't do one twice. It can fail at one, but it can't do one twice. It can't do what people often talk about with this thing where they're like, it's a double feed. It's not a double feed. There's no such thing as a double feed. Feeding happens once. What happens is it looks like something fed in on top of something else, but the break is actually back here, somewhere in the extracting and the ejecting. The thing did not extract and eject properly, so then when feeding happened again, you had a chamber that was still full, and now you've got what looks like a double feed to somebody that doesn't understand engineering, but it's a incorrect thing. And when we speak incorrectly and look at things incorrectly, we will never fix them. That's one of the things I tell you guys about troubleshooting. If you can't properly like identify what the actual problem is, and you're back here looking at this for double feeds, which can't happen, but you should be over here looking at why this isn't happening. And this is, again, engineering. We understand that engines always input, process, and output in some way. Some of you are going to go, wait a minute, that's everything I did for 4 years in my computer science degree. Yeah, it is. Yep, that's it. That's what you did. You did input, you did process, aggregation, collation, organization. You did all kinds of things here in process, and then you output something. You put it in a file, you put it to standard out, you tossed garbage to standard in, you threw logs out. Logs probably shouldn't be coming here. They should probably be going during the process, but we're going to talk about that. But this is why why are we engineers? We build engineers, or as engineers, we build engines, things that cycle. And then, if we understand, so why engineering, right? Now, with engineering, we can model systems to teach and understand. If you guys have ever heard of the OSI model, the OSI model is by the ISO, the International Standards Organization. They made the OSI model, which is this 7-layer model that we use to teach networking. If I want to pull it up for you guys from one of my other talks, this is not this talk, but we have one. What do we call it? We called it like primer. Hold on. Hold on. Let's just pull this up for a second here. Get out of here. Get out of here. Get out of here. Here is, at a real quick thing. This is from a different talk. This is the OSI model. And it allows us to look at a thing. And if I wanted to sit here, and guys, I'm not even exaggerating, and some of you will probably think I am, but those of you that know me know I'm not. I can talk to this data model right here without being superlative, without repeating myself for probably over 20 hours. And you say, really? Yeah, I've taught this thing for 16 years at the college level, this model right here, right? Reciprocal procedures versus functions, very different design methods. Sure. And I'm not getting into very specific things because I'm definitely not a software engineer. I'm more of a systems engineer and network engineer, but engineering is engineering, right? And this is, guys, so what I was just talking about with that other thing, I haven't even identified what it is, but if you guys want to look up what it is, you can from those 8 functions that I showed. This is networking. And did you know that it has to go down the stack? And if something breaks here, where my system never gets to generating a packet as we're going down through, this is where I need to look for the break. And if I send data out and there are data flowing as bits across the network, and they never get to the other side, well, now I got to figure out what the heck's broken. This is why ping is ping is one of the best things ever, because if I'm over here and I can ping this guy over here, I know that we're flowing here, right? I know, and I joke around about it a lot, but this is really how a lot of sysadmins are. If you used to call like your networking team and say, I can't get to the server, and they're like, give me an IP, or, give me the domain name, and then they ping it, and then you ping it, they just hang up on you. They're like, I can ping it. Absolutely. So the data are flowing down and then they're moved over. But if we look at this model, right, if you knew nothing about networking, and I just started saying, okay, guys, look, there's all this stuff. There's this giant elephant. And you guys have heard this expression from me before, but how do you eat an elephant? One bite at a time. How do you learn systems engineering? One bite at a time. So if I came here and I said, all right, guys, we're going to talk for like the next 20 hours on this, and then I just start meandering around here like this, I look like this is what I'm doing here, right? I'm like, oh, I can't draw on this one. I have to, anyways, I was going to draw on it, but I'm over here talking about session and then presentation, and then I jump down to network, and you guys would be like, oh my God, stop jumping around. And I say, okay, no. The first 2 hours, we're just going to lecture the physical. We're going to start with, there are ones and zeros. All of this data comes down here, gets expressed as ones and zeros and sent across a line. Okay, when I say a line, it's some type of medium, right? There are multiple different media, right, that are sending, we can send data over. They're typically broken out one of two ways. There is the physically connected media, and then there is over air or wireless media. So there's wired and wireless as like these broad things. And then I start breaking, and again, I'm breaking down right here. And then we go within the physical, within the wired, there tends to be either copper with which we flow over electrons, or there is some type of core, and that core is some kind of thin, clear material that we pass photons through as light. Those are the two major ways of that. And I just sit here and I break this down more and more, right? Again, that's not even what we're talking about. It's just that we can model and teach systems and understand. Then I jump over to the wireless and I say there's different ways that we do wireless. We do either RF transmission or IR. RF is energy in the form of electromagnetic waves. Electromagnetic waves are both electrical and magnetic, and they operate at different polar, so they are always horizontally relevant to each other, right? That's something. And then the other one is they can be photons again. Oh man, these photons are moving again, as direct line of sight lasers of some type. We can also get around direct line of sight by bouncing lasers off of things. That's neither here nor there. But oh, hold on, guys. I got a really bad headache from earlier. Like right as my class, I had a college class tonight that I was teaching, and right as I started to get to it, my head fucking just blew up. So I have like my head's hurting. Yeah, fiber optics fall into the wired side, yes. And then on the wireless side, you have you can just use what we call like open air or free space. Some people call it free space. All right, hold on. By the way, with electrons and the differences being electromagnetic waves or electrons inside of a cable, and then photons in its own fiber optics or photons in free space. Photons do not ever collide with other photons. I don't know if you guys know that. You can just send it, and they can bounce all over the place, and they never matter as long as they're not being picked up on the far side. However, electromagnetic waves do interfere with each other, and electrons crossing through a cable also affect each other. And the reason that is, if anybody wants to really get down to the nitty-gritty, is because photons don't, okay, they do at some like physics layer, like really, really low, they do have some basic friction, but not in any measurable sense that matters. It's like a rounding error off the problem. But electrons 100% have massive amounts of friction, and they do cause those type of problems. So if I was sitting here and we were talking about that, we're not necessarily talking about that, but we could draw out the actual waves. We could come here and where are we at here? I could go to my little thing here, and I could start to talk about, here is a sine wave. It's the worst sine wave ever drawn, but it's a sine wave, and it oscillates. And between when it oscillates from here, for one full oscillation back to here again, if that were to happen in 1 second, so if this right here was 1 second, then this would be 1 hertz, right? And however many oscillations, so then you start to look at it and you go, okay, hold on. What's the shortest point? If I was sending from here to over here, what's the shortest point between two lines? Isn't it always a straight line, guys? Yeah, actually, the twisted cables keep the electromagnetic interference from affecting the other lines. Yeah, that's 100% right, Twisted Seed. And I don't know if you know this, but if you guys take if you take a 100-meter cable, 100 meters, that's the farthest you can go, but typically it's 90 with an actual horizontal. So you take that cable and you cut it open and you take out your brown, your orange, your blue, and your green, and then you unwind them and you leave them at 100 meters. Did you guys know that the twist rate of each of those cables is different? And you will have different lengths of those pairs. The pairs themselves will be the same length, but all of the cables, when you're done untwisting, because there's 8 total cables, right? There's the white, green. So it's like the white, green. Sorry, it's the green and then the green, white, and then the orange and the orange, white, the brown and the brown, white, and the blue white, right? Those are the 4. Anyways, when you untwist them, they will be different lengths. So that's something to think about. All right, anyways. So anyways, where I was going with this is, if I told you that this is actually a shorter distance than this, and that's true, as we started to increase frequency of, again, guys, this is not even what we're talking about. I'm just showing you this because this is, in my mind, this is an interesting thing to note. If I had this, which is a higher frequency, in fact, over the course of this, that's like, so this is 1, 2, it's 2.5, let's say 2.5 hertz. And if you didn't know anything else about energy besides the fact that I just put more in there, and is this now going a longer path than this, knowing that rule that the straight line is the shortest distance? And the answer is yes. This right here is longer than this, meaning there's more friction. If there's more friction, what is there always in a system? Always more heat. Always. You guys know? I mean, look, did you know that the reason that the old phone systems, the reason we used to be locked down at 56 we used to be locked at 56 kilobits. Do you guys remember that in our old modems? The reason is because if you put much more hertz into a system, the phone lines could take more, but you would burn people's houses down. Well, yeah, Robodom, that's part of it. As you put more, I mean, it's always a cooling problem. It's always a cooling and dissipation of heat problem inside of processors. I think I told you guys this the other day, and I won't speak specifics on it until after it's released. But my company Redline, we are going to be working on with Dell and NVIDIA. They've designed this chip. And we're going to be putting it in some systems, and we're going to be building the fastest supercomputer in the world. We already work on a whole bunch of the top, like, 50. I've shown you guys before the ones for NOAA, which debuted at 37 and 38. Yeah. But look, all this stuff that I do that seems like high speed and eventually, like, becomes, very big complex systems all come from understanding of the basics, guys. All of my stuff comes from the basics. All right. So, yeah, as you introduce more hertz, you increase frequency, which actually increases distance, which increases friction, and there's more heat. That's also I just want to point out something. If there was noise, which in a data system there's always noise. And I showed you this signal here, and I told you it was being affected by noise, but it's shorter than this one here, and this one is longer. I mean, this is actually almost the same signal, just over shorter time. This one is going to attenuate faster, so higher frequency signals attenuate faster than lower frequency signals, which is why AM reaches way further out into the country, which is amplitude modulation, as opposed to FM, which is frequency modulation, which... There's a carrier wave. We're not getting into this. But if we were getting into this, if we were going deep into this, I would be able to show you any of these pieces here, and we could walk through it. And that's why engineering is important. I show you guys this. This is the simplest communication model known to man. There are always 5 pieces: a sender, a receiver, a message, a medium, and noise. Those 5 things always exist. You will never find something that's simpler than that works. I don't care if it's an ant talking to another ant through chemicals. It'll always be this. I don't care if it's a cell in your body talking to another cell, or something in your body that's a communication protocol for either your electrical or your anything. There will always be these 5 pieces. It's never simpler. It's not possible. Communication doesn't occur without that. So this is called the simple communication model. There's one that's one higher than this that I don't include in this talk. It's called the effective communication model, and it adds a 6th piece, which is a feedback loop to let the sender know that the receiver was there. What if every time I stopped talking, I was like, "Did you get that, Robodom?" And then I just sat here until Robodom typed back to me? That would be insane, right? You guys would be like, "Oh my God, please stop doing that." Morrison, I have a network primer on YouTube. Yeah, if you go on YouTube, I have this primer right here. Yeah, this doc is also up there. Yes, but this document right here is this network primer. I have a YouTube video on all this. Yeah, I need to update it too. But this is like everything we walk through. And over here, I painstakingly built all this on the right so that at each layer, you can see which layer we're talking about. You guys see this up here? So whatever layer we're talking about, there it is. It's showing you up there. Yeah, that's on YouTube if you guys want to go look at that. All right. So why engineering? Again, it's easier to teach and understand because all these things I was just talking about, you would have known that it was in the context of the physical layer. So remember I was saying I could talk for hours and hours on this. I haven't even started to get into this. This is like bare, like first class stuff. Right, like, but we could do that, right? Like I tell you guys, like if we want to talk about the encoding schemes of how we put the data down onto the line, that starts getting really interesting. That'll be up at the data link layer, though, right? How do we actually access the system? Oh man, guys. Also, sorry if I feel like I'm moving a little slower today because I have a killer headache right now. So. Again, this whole talk is why engineering. So on this next slide, why engineering? Because we can report output for variability. So I can start to take something like firing, whatever this firing is, and I can have this test 1, 2, this ... as an ellipses in engineering. If you're not used to it, it just means all the tests in between that I didn't want to show you. It's kind of like in engineering when we draw a cloud. Right? But it's all the tests in between test 4000, which is this. And then now I can take this variability and I can start to do math to it. So I can take that variability and I can start to improve things. I can say, okay, well, across all my tests, I have this center line and I can use a histogram to determine what that kind of looks like. And then the histogram will show me a standard distribution of data. The standard distribution of data, or sometimes you'll have different types of distributions of data, but this one's starting to look pretty standard. And maybe we just zero out this number 2300 because we find that that's near the middle, and then we, figure out where things are above and below. As you have more and more tests, and as you have more and more data points, then you can start to calculate what's called the mean, the median, and the mode. And YouTube said, is the networking primer video on YouTube? Yes, it's on. Yep. That presentation I just had up and the talk with it when I was giving that talk is on YouTube. Yes. It's one of I think I only have a few videos that are actually not just us being live and hanging out and talking about being in the Linux group. Because again, I tell you guys, the whole reason I do this stuff is to get you guys down into the Discord, right? Discord's free. Never charge you anything for that stuff. You don't even have to do any of that boosting stuff, right? Like that's all for people that want to do that. But Discord's just a place for us to hang out and share memes, and people can come in and find this stuff. So, all right. If you say, Scott, this is a lot, but this is stuff that's interesting to me, then we jump back over and we do this. We come back here. And we go to this Six Sigma stuff, right? I'm gonna pull this up for you guys. I don't normally pull this up, but we're gonna go look at Six Sigma. This is free. This is one of their free things that are out there, right? Let's pull this up right here. Six Sigma. You can go take the test for free. I think you take it a couple times free over the course of a few months, but it's free. And you say, well, I want to study for it. I need to learn. I want to get something on my damn resume, right? I don't have anything on my resume yet. I want to get something. So we'll go look at this PDF right here. And okay, they present all this stuff to you. I don't know why they're saying reset that. All right, and I'm going to go here, and I'm going to say distribution. And I say, here's the development of a statistical process control. Wait a minute, weren't we just talking about if I can model things, if I can record output from my system at any different part of it, I just happen to pick the fourth operation here, then I can take that model of variability to improve it. So hold on, I'm going to come back here real quick. Move this out of the way so you guys can still see me talking with the closed captioning. And then now I can start to learn about the roots of statistical process control. Okay, guys, I got to learn about the mean, median, and mode. I gotta dust off something that we did way back in like grade school, right? Maybe even into high school. And this is, well, hold on the right here. I just want to see how far down I am. Okay. And the white belt level doesn't really make you go very far into it. Let's see how much math there is actually at the white belt level. There's not really much. Nope. They want you to understand this math right here. And really what they want you to know is that Six Sigma deals with this right here, that if we can get to Six Sigma in our processes, in our process improvement, we would only have 3.4 defects per million opportunities, what we call DPMO. It's the number of opportunities for a defect to occur, the number of defects divided by the total number of opportunities, and then times 100 would equal the yield. And for Six Sigma, we want to be under 3.4. So if you think about it, if you were building bikes and there's 20 things, there's 20 steps to building a bike, let's say. And across, so now 20 to get to a million. Hold on. So we go a million, right, divided by 20. You got to build 50,000 bikes. And across 50,000 bikes, with those 20 steps each, you only have 3.4 errors in any of those. That's what process improvement is. And you might say, well, Scott, that doesn't even sound like technology. It's not. This is aerospace. This is this is sound engineering. This is every type of engineering. And this is why I try to show this to you guys is go knock out a couple of these certs for free. Some of those Six Sigma certs that are free. And then maybe you're like, oh, that's interesting. I'll go to one of the paid ones. That's up to you, right? Because people do, if you go look on like DICE and some of these job sites, you'll find that there are people looking for Six Sigma green belts and black belts. It goes white, yellow, green, black for them. Yeah. But what you do is you start to figure out, okay, here's my process, here's my standard deviation. Okay, how do I tune, like if I want to get back to the center line, how do I do an upper control limit and a lower control limit? How do I tune my process? What was happening when these different things happen? And we start to like ask, in engineering, we call it asking why 5 times, if you haven't heard that expression. Well, why did this happen? Why did that happen? Why did this firing happen different than the other one, right? And you start to, but the point is you can model variability and improve it in a system. All right. So why engineering? Again, because we can log in checkpoint. We can say chambering, and we can timestamp it. And then with a timestamp, we can use a standardized timestamp. You guys, some of you have been around before. What's our standardized timestamp that we use in systems? I talk about it all the time when we do Ansible, and it's very common in any of you that do cloud. You get all your responses back. No, Rob, no, it's not UTC for this. UTC is shown in this frame. It's ISO 8600. ISO 8600. Hey Hadler, thanks for the subscription with your Prime. You could use that anywhere, and you chose to use it here, so that's always fun. Make sure you refresh your browser though, just because like I've heard of people getting ads. Even if you do that, that's good. You guys don't ever have to pay me anything, but it does kind of, it's cool for me because it's like it's a motivator, you know. And I can show the wife, I'm like, yeah, I made $100 this month, and you said that I was never gonna amount to anything. No, the wife's never said that to me. The wife's never told me I'm not gonna amount to anything. All right, but anyways, look, so we can timestamp. logging and checkpointing things. But I bet some of you already see the problem here. If I know that step 2 happened, I know step 8 happened, well, there's a lot of questions that this slide begs, I bet. And hopefully it's answered in the next slide. What if something happens? So why engineering? Because we can troubleshoot. Well, what if we never got down to this process of caulking down here? What? It's caulking. C-O-C-K-I-N-G. Are you not going to say it? Oh, I thought my stupid thing, because it won't say like a bunch of bad words, and I thought it was going to say that's a bad word. It's not a bad word. At most, it would be a type of chicken. All right, anyways, the point is, you never got to this step. So that means something broke in here. So then a bunch of you would go, well, what broke? And I would go, well, maybe this, and maybe this, and maybe this, and maybe this, and maybe this. So most of you are probably then like, well, that's stupid, Scott. Why would you just log on 2 and 8? And you're right. So maybe we add one more in. And then now why engineering? Because we can think about granularity and resolution and monitoring. So why don't we just timestamp everything? Well, there's a cost to everything you do, guys. It's just the cost of logging is so low nowadays. And the tooling and the libraries that are out there to just log shit, you should just do it. You should just log stuff out. Send it to a log. Send it to, if it's just key value, if it's data, if it's histogram, if it's some of that stuff we were talking earlier about, like just output values, then you could just start throwing that stuff to like a key value store, and Prometheus is always ready for that, right? Prometheus is great for that. It's literally a key value store with literally hundreds of different exporters, and you can even write your own exporter. But there's so many of them you don't have to, right? But look, I mean, just look at this. We added some more logging, and then now, if we know we got to 4, then we know that something had to break between 5, 6, and 7. Hey, Less Than T, how's it going? Thanks for your resubscription. You've kind of always been around, and I appreciate it. So, well, that's kind of cool. Oh yeah, there's no hype trains around here, guys. We don't do those things. We don't do that here, right? We don't do that here. Wait, where's the thing? Oh yeah, wait, hold on. Where's that? It's right here. Oh wait, is my thing busted? Hold on. Where's that? Hold on. My, what the heck? Hold on a second, guys. I gotta switch here and back here. And then, is this thing plugged in wrong? Hold on, I gotta check something here, guys. I think my stuff's all messed. Can you guys hear me again? Oh shoot, this is not good. Oh no. Oh no, I killed it all. Test, test, test. Okay, hold on. Test, test down here. Okay, can you guys hear me again? All right. I switched my USB between the two, and I was like, wait a minute. Oh, there we go. Wait, where's it at? I can answer that for money. So I must have my stuff in the wrong places because my key bindings weren't working on my mouse. I have some mouse key bindings here. This is me. I'm just a guy who teaches people Linux for fun. And in this case, we're just doing engineering. But all right, so something broke down here because we never got to here. But the point is, you can be more granular about your timestamps. In this case, firing was complete. Maybe that before that, it also gives us that output, so it's easier for us to do our data collection, and then we can do variability and all that kind of stuff. And your timestamps and your logging can show, you know, what happened, and maybe you start to have some metrics in there collected as well. Although metrics tend to be collected separate from logging, strictly speaking, but they're still, at the end of the day, they're all about granularity and kind of resolution of like what you want to know. We just break out, you know, whether something's either a log or if it's metrics of some type, and then, you know, that makes it easier for us to monitor whatever's going on. All right. So again, why engineering? Well, if we can be engineers, then we can hack. And hacking is a subset of engineering, and I'm going to show you guys that here in a second. Hacking has, well, probably in a few minutes, but hacking has nothing to do with getting into systems. It never has. That's typically like a function of what's called cracking. Hacking is the idea that you keep sending different input to a system to see what its output behavior looks like. That's what hacking is. Hacking is understanding a system by mapping the input and output behavior. Now, you can do that faster by going and reading a man page. So that's why we talk about RTFM, which is read the field manual, right? But I can maybe start to feed in some random structured input, right? 1, 2, and 3 up here. And then now at locking, I get some error code out. And then at unlocking, I get some other error code out. And then at cocking, I get all the way to the end for the third test. So I put these 3 different random tests in. And I just got these weird errors. And my engine, because again, we're engineers, the cycle of this thing behaved a certain way. And that's what hacking is. That's exactly what hacking is, guys. There's nothing special about it. Okay, so now if we can hack, we can secure our system. We could start to say, well, why the hell am I allowing somebody to test by putting in these different random inputs? Why are we responding to any of this? Why did we ever accept that input up there and feeding? Should we have maybe authenticated a user first? Should there have been up here? Should we have implemented the AAA, which is authentication, authorization, and auditing? Again, guys, as we talk about this, and I keep asking why engineering on each slide, this is like the most generic talk. This has nothing to do with technology, really. It has to do with what engineering is, and we're just applying it to technology. I apply it to technology because I've been an engineer in the IT space for 20 years. But these things, you could be a kite builder doing this. You could be, again, back to the bike thing. Yeah, these are skills used by engineers. And we keep asking why engineering, because now somebody was hacking around that shouldn't have. Now, if I was hacking around, I was just doing engineering because it's my system. But if somebody else is hacking around, why am I accepting their inputs? And that the difference between this and this becomes kind of the crux of all IT security, right? Those two things. So then if we are getting compromised, we can secure against intrusion and describe the events in a structured way. This is what's called the diamond model of intrusion analysis. And you guys, hey, Street Track, how's it going over on the YouTube side? I'm trying to keep up with chat and watch you guys and see what's going on. I'm just giving a little bit of a talk around like why engineering? Why would we be engineers and that kind of stuff? So we've gotten down to, because if we use engineering and then we have ways to teach it and then we have ways to stop, well, we have ways to define what hacking is and then how to secure systems, then we need to be able to tell other people what happens. So the diamond model of intrusion analysis is this great way to look at attacks. There's an adversary and a victim. That's the social political axis right here between the adversary and the victim. The adversary, for social or political reasons, are trying to attack the victim. Maybe they want to do it for the lulz. Maybe they want to do it because the victim is, I don't know, pulling too many whales out of the ocean, and they think that's bad. And maybe they're doing it for nation states and for, there were huge cyber attacks, if you guys remember, early on with some of the Starlink stuff in Ukraine and that kind of stuff. And you guys can go look up. There are actually reports that are written in this model. This is a very common model for talking about what happened. It's the infrastructure of your system versus the capability of their system. So your infrastructure is secured with whatever methodologies and technologies you're using. This is called the technological axis. And are you able to stop whatever they're trying to do? There was an attack. There was an attack that I'm sure will go through this process about 2 hours ago on the internet. Who knows what just got attacked about 2 hours ago on the internet from when I was given this talk? It was probably the most talked about thing on like social media sites for, like, it was probably like one of these things, and good or bad, whether you like it or not, it's an American political thing. It happened about 2 hours ago, two and a half hours ago, and then it was hacked. There was a huge DDoS of it, which is a distributed denial of service. And this report will come out about it. Somebody will do a report on this here soon. you guys, it's going to be a technical engineer probably from their company and whatever they choose to release. That's always true. But anybody know? And I'm not trying to get political, guys. I don't get political, but does anybody know what happened about 2.5 hours ago on the internet? There was a huge denial of service against it. All right, I'll let you guys think about that. So, that's all cool and all. Yeah, it was a DDoS, a distributed denial of service. Yep. So that's all cool and all, but why engineering, right? Like, I talked about all those things. It was that, Fisherman. Yeah, they had tested that over 8 million people should have been able to be on there, and I think there was less than like 500,000, and people were just complaining that they couldn't get in. I was kind of watching X while the other teachers were talking in we do like a team teach, and I was doing all the labs today. I was showing everybody labs. But anyway, so that's all cool, but why engineering, right? So why engineering? Well, engineering is because no one's going to pay us to hack. Guys, look, I'm telling you, I was the technical lead for the red team for AAA. And people think like, oh, I want to go be a pen tester. I want to just hack the systems. Well, pen testing is part of that. But in engineering is a larger process. This was actually funny. I should have redone one of these with pen testers in there. Because man, I would watch our pen test. I would go and sit in these meetings because, again, we had like 200 different app teams that were doing stuff. And let's just take that word hacking out of there and put pen testing in there for now. There would be weeks and weeks of planning, weeks and weeks, like maybe like over 2 or 3 weeks of planning. Then they would go and they would sit in their basements, and they would typically work nights because that's when they would be allowed to do stuff against our system. And they would have this limited scope of what they were allowed to attack. And then when they were done, maybe they did that for 2 or 3 weeks. They would spend 2 to 3 weeks writing up all their reports and documenting findings and stuff and meeting with the teams and working to work that stuff off. And like, there wasn't that much of like what people think are the fun stuff. Yeah, there's a huge amount of planning that goes in and then documenting at the end. And the stuff where they're sitting in their hoodies at night going, I'm in. Hackerman, I'm in. That's very rare, guys. Or that's less than 50% of it. Right? And maybe they've got some standing orders of things they're allowed to do all the time, but I mean, good engineers are going to automate a lot of that stuff. So it's not like you're solving a lot of the same problems over and over again. You're doing that. So again, the question here is why engineering, and it's because no one's going to pay us to hack. Nobody wants you to just slap together some servers and give them, 30 servers that are like barely holding on, and you can't warranty that they're going to stay up for the next week. That's not what people pay you for. And in your organization as an engineer, getting good at some of the tools I'm going to show you here in a little bit is a big part of being a good engineer across the board. I don't care if you're a software engineer or if you're a network engineer or anything. It'll be generic, right? So this is the first part of it, right? So look at this model. There's planning over here and documenting at the end. Hacking is the stuff where we go figure it out. Anybody that's even listened to me for more than 5 minutes, anybody that's joined a professional Linux users group, they're probably fine with this part of it. They've hacked through and they've built some Linux systems. They've built some little tools and got things running, and that's fun. But now, how do we get better at the planning and the documenting? Okay. Fastcon, you just finished part 2 of your penetration testing class. 80% reports, 20% hacking. Yeah, I'm not surprised. And now when you go into doing it for a business, there's more planning too. Because the planning is, what are you allowed to touch? What are you allowed to knock over? What if I get to a database, right? Like I'm doing some black box testing. I don't really know much. Maybe it is typically more gray. Like I know the stuff that is in the domain, but then maybe I find maybe I do get into something and I go and I start poking around. And I find a database. Am I allowed to like push on that database? Am I allowed to like put a little bit of like, I see that it'll just allow anybody to connect and try passwords. Am I allowed to? Yeah, your rules of engagement. Am I allowed to go push on that a little bit? Or when I push on it, is it immediately going to fall over? And yeah, like what's allowed? This is a big part of this, guys, right? So, all right, so here's how, this is my thoughts on, again, oh guys, my head is killing me. We got a plan. And planning is typically like a function of the business. So these are the things that we need to get better at as engineers. Model the high level steps of, because you're going to be building new things that look like old things. If you're a systems engineer, you're going to do a lot of building new systems out that look a lot like the systems you've built before. Maybe they're just a newer version. I know for some of you software engineers, you're grabbing the same code framework again. Like if you watch Salty Catfish is one of our guys that streams, and he comes down and talks in our Discord. He was down in the Discord today, so maybe he's even on stream. But when he starts a new Python project, which he does almost every stream, he shows you guys starting a new Python project. He does it by building a brand new virtual environment and pulling down the tools that he needs, and he does all of these things the same way. And guys, he's been a software engineer for I think 12 or 15 years, and he's successful at it. He's had a career, and he's been a lead, been a technical lead doing stuff. And I watch him do it. He sets up his environment the same way every time, and that makes him more successful at what he does. So modeling the high level steps of the thing we're creating, deploying. Guys, you're going to find these patterns in engineering. Whatever you do, you're going to find these patterns that are always the same. I actually heard this. I was at Lockheed Martin, and I was doing this meeting. It was for people that were there under 5 years, and they brought in these older engineers that were around. And this one engineer came in, he had a ponytail, and he had been at Lockheed for 35 years, I remember. And he goes, guys, I learned very early on that if I just kept good notes, every time I went to a new security team, or not even a security team, an engineering team, he goes, they're dealing with the same problems that I was dealing with on the other ones, and I just look like a rock star because I was doing the same things over there for them. And that's exactly what engineering should be. All right, being able to outline is critical. You should be able to take a set of steps and outline them, and then hopefully, and this is a skill that you're going to get from previous knowledge and watching people talk about it and talking to other engineers, how long is it going to take? Being able to estimate your time and being able to give a swag. Anybody know what swag is? But you got to be realistic with time. You can't be Scotty, that Star Trek engineer that would always come in and double how long he thought it would take to look like a hero. You can't do that. It's funny, but it's not good engineering. Not even, it says not great engineering. It's not even good engineering, right? But what's a swag? Who remembers what a swag is? All right, I'm going to take a break. I got to take a break real quick. I'm going to grab some more water too. Man, my head is... let me pull up my hourglass. Take a quick break. Do you guys want me to see if Ranger Cam's on? I haven't checked Ranger Cam since I got home. I'm going to do 8 minutes. Quick break. Quick break and think about swag. What's a swag? Does anybody know what swag is? Some of you guys know. All right, I'll be right back. Well, that's kind of annoying. This thing wasn't actually running. Gotta have the GIF running. I never even thought about ponytails with swag. No, swag is stuff we all. No, it does mean stuff we all get. No, it's a scientific wild ass guess. So swag is your scientific wild ass guess, but it won't say the word ASS. Will it say assassin, which is simply a killer with two butts? That's my wife's favorite stupid little pun. All right, we're on break, guys. Feel free to take a break. I'm not going to talk about anything serious for 5 more minutes. I'm just going to sit back in my chair and think about why my head hurts as much as it does right now. And by the way, guys, this talk was specifically designed when I was putting this together and gave it to the group. It's designed to not really be just for IT engineering. It's supposed to be just generically around engineering, and you could apply this to sound engineering and waveform engineering, which is very similar to sound engineering, and laser engineering, and this should be generically around any type of engineering, really, right? This wasn't an IT based, although some of the things I talked about were tuned towards the IT side of things. All right, I'm still on break. If you guys have questions, you can drop them in chat. We're just kind of hanging out. Let's probably pull up Ranger Cam. Check on Ranger Cam. I haven't checked on Ranger Cam since I got home from my travel. Let's see. Oh, gotta log in. Give me a second. Nope. There he is. There's Ranger Dog. That's Ranger, laying on his bed. Nobody has to do a Ranger check. We're checking on him now. My head is killing me. My head. Yeah, whatever. All right. 2 minutes, 2.5 minutes on break. Go grab a drink if you want it. I probably should have set my break a little shorter, but that's fine. Ranger's having ranger dreams down there. Alright. Fisherman, you still around? You're not causing any problems, so I don't think you're around. He normally streams around this time too, but he's a few hours later than me. Alright. Fisherman, you should stream, man. My head is killing me. I'm gonna get through the rest of this, but I gotta raid somewhere here soon. So, all right, we'll go over what we already did and run into the rest of this break. So, talk about model high level steps of things. We need to like understand things, right? Like this is the more we do stuff, the more we understand it. Outlining is a big part of that. Estimating is a big part of that, and then predicting problems is a big part of that. There's a thing that's been used by the government since the 50s. It's called Failure Modes and Effects Analysis, FMEA. And I have a different talk that we talk about how troubleshooting works and what FMEA is. But this comes from previous knowledge and being able to map, well, I think all these different things could happen. And then we start to model that into like actual numbers. Like, what is the thing? And then once we have actual numbers, and we've organized things, that's called triage, right? Triage is this thing that people know from like battlefields, like, oh, this person can't breathe, and this person's bleeding out, and this person's just a little cold and stubbed his toe. Well, now look, not breathing will kill you first, not having blood in you will kill you second, and then stubbing your toe will probably never kill you, but would kill you last of those three, right? However, depending on how much that person's bleeding, you might want to help, right? So this is like how that works, right? So anyway, yeah, predicting possible issues and problems, that's failure modes and effects analysis. We'll reset that, move it out of the way. Failure modes and effects analysis. So then we want to, in planning, be able to build like a minimum viable product or a proof of concept type deployment, like be able to stand up the basic thing that we could then hit with like maybe we just have a basic little, there's a project that Fisherman built on Killer Coda. We go back to Killer Coda real quick and we go to Fisherman. Where's this stuff? Yeah, this is it. One of the things here is you could go take this little local LLM, and you could build up this little tiny llama thing, and you could have a little API that then you could test. So like some of you are probably paying money to hit an API for like you're building an application that does maybe some chat botting or some different stuff through like a large language model or whatever, right? And you're paying to like test your model against like some, one of these open things out there. And when I say paying, maybe you get the first 20,000 free, but you're doing regression tests and all these other things on your little tool, and it's costing you money. But you're literally throwing out 99.9%. You do not give a shit the answers. You just need something to bounce an API call against, right? Well, one of the things about this is you could just stand this up. Like, you could run Olama on one of these systems here, which has one processor and less than 2 gigs of RAM. You can run that. And that stupid little thing that's not doing hardly anything would be able to respond, and it would be from your own machine, and you wouldn't pay anything for your 20,000 requests. And guys, I don't know what the cost is. I mean, 20,000 requests against APIs for LLMs right now might be free. I don't know. But the point is, whenever it was going to start costing you, because, again, you don't really even care, and you don't even care. It could just be giving you junk back. You don't care. This is a nice little way. Or maybe you do care a little bit, because then you're going to feed those answers into something else. This is at least a way to start to build a proof of concept. So you could go run through his lab here, and you could go take that same stuff and build it on a machine in your own environment, and then you'd have something to bounce off. That would be a minimum viable product, guys. It would do enough to check all the boxes in that I have to hit an API with my tool. My little bot is going to take some input, and I'm going to be able to test those input as a bunch of web calls that I'm just going to fake. And then it's got to process whatever you're asking, maybe do some input validation, maybe take an API key in and verify that you are, somebody who's authorized to do it. And then maybe those API keys, like up in the cloud, we can even use that to throttle how many times somebody can do something, right? Because that's giving like access and chargeback later. How's it going, Doc Mallet? We're just talking generically right now. We're not like getting super deep into anything. We're just talking system stuff. But building out that minimum viable product, right? You can then have this thing that does all the things, but it's not really fit for warranty. Like, I can't drive this thing down the street. I can just hit it with some basic things and test on it, right? I wouldn't take that little llama tool, that little tiny llama, and feed it out for everybody to look at and like I wouldn't like sell that as a service or something. That's not really what that is. That's not really how that works. All right. So the other side of it, right? We're back here. Engineering is hacking in here in the middle, but you got to plan first. This is planning. And then you got to document at the end. How do you get better at documenting? Well, how do we apply documentation to the end of our hacking, right? Well, you need to take notes. Taking notes, your system can do a lot of the note taking for you, but that's going to be what we call like system overload or a lot of noise being generated. So what I like to do is, like, I like to pull relevant commands out and throw them in Notepad, OneNote, any other tool. You guys have seen my OneNote, or I say OneNote. I use Notepad++ a lot. One of my favorite tools. You can use it in dark mode. It'll do. Let me make sure I have it on the screen. I can show you guys. I'll just show you guys this. This was something I was doing on a project, and this is different enough that it's not actually for the customer, right? This is still unique, and I can go in and I can look in. This was something I was going to do. I was going to go copy some of that documentation because I was in a skiff and I couldn't reach out. I couldn't go do. You say, well, why didn't you just download this when you were working at it? Because when I was in the environment, I was in a skiff. So I needed to download this at lunch to go with all my other notes. And the tool I use for that actually is a pretty cool little tool. I don't know if you guys have ever played with Zotero, but you can go and you can download a page and you can view it as a snapshot. And this is a snapshot on my local machine of that web page, which is super useful. Also good for note taking, because then for some of you guys that are doing any work, you can make your bibliography from it right here. So I could, I think I copied that. I think I just threw it to, yeah, and then now that's an actual, this right here is actually a APA 7 formatted resource, what they call resources, right? Oh, but then anyways, down here, this was me configuring this portal. So I was doing LDAP, and I was configuring, yeah, you can't typically have a skiff. You have to, in my environment, I have to turn that off. But you can come in here. This is a great tool, man. You just right click on shit. And I did this for my students. I was showing this to my students. Actually, no, this was for, this was one of my college classes. I actually was using the NIST one that I'm always showing you guys. Let's see. Oh, you can actually open the PDF. So this is just an awesome tool for just grabbing stuff and keeping track of it and that. LogSec is good too. Yeah, I use LogSec. Do I have it? I don't have it up right here. I thought I had it on my thing, but yeah, I've been using LogSec for kind of my raw notes now too. Let's see if this comes up here in a second. Looks like it's trying to start somewhere. Where you at, LogSec? There it is. And for some reason, mine is back in white mode, which I prefer the darker mode. So go to themes. Whoops. It's actually weird. You got to go to, I think, settings on this one, and then you can set it right there. And then some people don't like that color, but you know what? That color is better than light mode for you guys, because I know it blasts some of you guys are probably like just hanging out, and then I blast a laser beam in your face, and that's the last time you ever watched the stream, right? Anyway, so again, take notes. And then I always clean up and prepare for initial documentation. So I will keep raw notes of like the process. And then when I go to do the process again, or when I get ready to do it, I'll make the initial documentation. Now, this is the thing. You got to learn how to do Markdown or some other documentation. Whatever tooling you're using, you have to learn it. And that's going to be different for different organizations. Some of the guys here work for, I know we got guys in our server that work for AWS and Google, and they use proprietary internal tools. That's what they do, right? So there's those kind of things. And then redline operations. When I say redline here, I'm not talking about my company redline that I work for. Redline operations is something I learned about at Lockheed, and this is super useful. So you go and you build your documentation. So you build your proof of concept, your device like this, and you'll probably have some messy notes, like my messy notes. And you'll take them out and you'll start to clean them up and start to get them ready to build maybe your second run. Maybe you blow all that stuff away and rebuild and test it, do your own little red line. But a red line operation is you give the procedure to somebody else on a clean system. You have a tester or some junior engineer on your team that was working on something else, and you say, okay, now I'm gonna, and look, guys, in skiffs, we used to print these out, and I'm not kidding. And one person would be sitting here like Pepe, and the other person would run through the steps, and if they got to a step, guys, if they got to a step where it was like, look at this, hold on, let's do this like we're actually Linux engineers for a second. If they got a step that was like this, and the step just said, you know, execute .sh, some script, right? And that didn't work because you weren't in the right directory, right? So now what you would do is you would redline that. You would actually go, hold on, let me, can I undo my last thing? You would actually redline through that, and you would say, you know, fix to the right directory or whatever, right on the document, right on the paper. And then you would go back and you would have to refix and clean up your documentation again from that red line. And then you'd have to take it. And the tester at Lockheed Martin, the tester was always another team. They didn't answer to us. They were what we called QA. If we were going to take this to a government contract, we were going to take this to some customer, you better believe that shit had to be clean, because our company didn't get to run that. That would go over to like Harris or Boeing or some other contractor that was on like the government project with us. And if anything was wrong, you better believe that they would go tell them that our shit was busted. So we would redline our documentation and make sure it was perfect. And you might say, is it really that? Yes. Because what would you do if you were running through your own notes, right, and building something? You would just go, oh, I'm in the wrong directory, and you would CD to the right directory, and you would run, and you would never fix it. I bet you most of you have done that. I do it all the damn time. You guys see me do it in my home lab all the time. But when you're getting ready to be an engineer, and you don't just want to be hacking around in the home lab anymore, this is huge. Being able to QA in what's called a red line operation on your stuff. So there you go. And if you learn something new, that's good, right? This is what we do. Yeah, Markdown's good. Markdown's valuable. Produce training and operational activities from your documentation. So we almost always have to go train others. We can't assume knowledge of the system, even if they have root level operations. I ran into this all the time. You make it idiot proof, they build a better idiot. So you have to assume they don't have any knowledge. They don't even know what a CD and a PWD is. You just have to show it to them every frickin' time. This has like a caveat. This has like an asterisk next to it right here. This thing that I'm saying. A little asterisk. Oh no, it's terrible. It's breaking. All right. Absolute pathing helps keep operators in correct directories. That's true. But it's bad. BAD for scripts. Let's say a script has to run as non-root. It can run, it's not really installing anything, it's setting up a virtual environment. So one of the things that the script does at the top is it grabs like the home variable, right? And then all through that script, it uses the home variable, because otherwise you were going to be, if I did absolute pathing in my script, that's my home S Champagne, docs or whatever, wherever I put the script, and then it's going to do a .execute.sh or whatever. Well, when it gets to your system, is that user going to be there? Are you going to be running as that user on your system? Oh, hell no. So absolute pathing is very good for documentation, like I'm talking about here. I'm talking about training and documentation. But it's terrible for scripting, where things are dynamically going to go somewhere else. Smur, that's exactly true. That's exactly true. So then this begs the question of, do I understand what absolute pathing is versus relative pathing? And if I don't, I have to go spend a little more time with it, right? right? And this is how we find holes in our game, and we plug those holes, and then we build up more. And so this was this section where it's like engineering is planning, hacking, and documentation, and I focused on the planning and the documentation, right? So then in conclusion, right, like, why engineering? Every question was why engineering, right? So this is why. Because engineering is worth good money. Businesses need their processes to run, and we know how to do it. This is my favorite part of the presentation to make right there. Was it's good money, right? There's good money in being an engineer. And yeah. I like this is maybe my favorite one, this one right here. But you know, there's these things. This is why we do engineering, right? And then I said, where do you go from here? Focus on being a better engineer. And then I think that's the last part of that talk. I have other talks that talk about like excelling in the engineering field after college. I've given that to my college students. I've given that talk to you guys too. And I just say, well, cross off college if you're not going to go to college, and that's fine. But now we have these other set of hurdles, right? Like everything you do is you have a choice. You could watch this stream and you can do this kind of stuff, and you can go hang out and do labs and do certifications, or you could watch everything that there is on Netflix, or you can go watch all of One Piece again, which has like 1,400 something episodes, or maybe even more now, right? So the point is, there's all these things that you can kind of do, and it's really up to you, like what you want to do as an engineer. But I told you guys I would do this talk and at least record it, so this will be up here for you guys that want it. If you have questions about that, I also have the slide deck up in the Discord. There's not really that many links in that slide deck that are important. I did that on purpose. I wanted this just to be a talk that was generic. Yeah, watching One Piece. Yeah, Robodom, that's wild. Yeah. But guys, this is all I think of as an engineer for all the years I've done it. These are this is the whole thing, right? Also, thanks for the follow. Kakzu is bot. Hopefully this stuff's useful to you. Hopefully you're not really a bot. But if you are a bot, welcome. You'll get this. If you're a bot, you'll get this. I'm just kidding. All right. Anybody ever watch Futurama? Bender's Prayer? He's praying in binary, and then at the end he says 2. He's like 101101. He's droning on, and then he goes 2. And you're like, you can't say 2 in binary. There's no 2. It's funny. Or a beach. Yeah. Okay, so anyways, that's that little talk. That's up there. There's not really any annotations we need. Look at Ranger down there. What's Ranger doing? He's not really doing anything. This was me. If any of you are wondering what this was around OOD, which is the Open On Demand, and I was setting up their LDAP system part of it. Which, by the way, you might be like, hey, wait a minute, Scott, you know LDAP? Not super well, guys. I had to go reference a bunch of shit, right? This is our engineering life. We have to read stuff and go, okay, I know a little about that, and I know a little bit about that, and I can figure it out, right? Oh, hold on, let me pull my... It doesn't matter. You guys don't need closed captioning. All right, here's what I'm going to do. I'll go find somebody to raid. You guys are welcome to, hang out down in the Discord. Robodom, do you mind giving one more if you're around? Ryan, hold on the YouTube side. I just started following you. Please advise, how do I structure my learning? I am drowned in YouTube videos. Ryan, go find a group. It doesn't have to be our group. And go find like a beginner section. And don't try to learn everything all at once, right? Like eating the elephant is impossible. It will be too much, right? And then pick a goal. Pick one point out there that you can go follow. Say, hey, I'm going to learn this API thing. or maybe that's not interesting to you. You're like, hey, chaos engineering sounds interesting. I'll go do that cert. That cert will take, any of these certs up here will probably take you, depending on how you study, I'd say 4 to 16 hours. These ones right here, between about 4 and 16 hours of study. And then the tests are free. And then you would have something to go put on your resume. And then as soon as you're done shooting that azimuth and going and finding that thing, then you go and you make another one. You go, okay, that chaos engineering, now I'm a little better at studying. I'm a little better at note taking. I'm going to go do this next one. And look, there's places out there, you know, there's groups. We've got a Discord people are welcome to hang out in. And we study some of these things sometimes and go through stuff. We were heavily doing Security Plus. One of our guys, Robodom, who's like one of our mods, he just passed his Security Plus, which is awesome, right? That's a big deal, right? That's something that can help get a job. I mean, that just opens more doors, right? There's more jobs you can search for with Security Plus. So this is what we do, guys. This also has some YouTube videos where I was showing some basic Linux stuff. And that'll get you kind of going. Yeah, he did. And then another one of our guys got his RHCSA as well. So one of our guys passed his RHCSA, and Robodom got a Security Plus. So that was awesome. And like, you know, this is one of these things, like, find a group that kind of cheers you on. And the security topics, you'll see every time one of us passed a cert, we would go, you know, we'd go in there and be like, hey, you know, kings to you for a day or whatever. Actually, I need to. I don't think Fisherman's still around, but I need to start generating when somebody has like a success like that. I want to start just generating like a kings to you for the day. Remember when I used to do those? Wait, I haven't done one in a while. Like, I would make these kings to you for people. When people would pass things. Oh, I don't know. Maybe I don't have a good example of it. I know where I have it in here. Hold on. It's in Linux group and probably streaming and then probably like images and like different people that have gotten. So B-Blade got his RHCE some while back, and we just made something like this. But I bet you guys could make those way better in your little chatbot AI things or whatever. You know, you guys doing all your AI messing around. But yeah, I used to make these for people and just post them up. Let's see, what are some of the other ones? B-Blade's got one. I might have done a different one with him, too. Hold on, what does this one look like? He got his RHCE completion. I took that off because I didn't use that one because I thought that looked like garbage. I think I was just messing around. What was this other one? YGBSM. He was one of our guys that wrote he designed this really awesome API Academy thing. So, and then I've been trying to make them better. But see if there's any other good ones. This is like reaching into the ancient time. This is the Ranger Unimpressed one that I did. Oh, shoot. Oh, well. Look at Ranger yawning. That dog. Hold on. I know it's super grainy. But it was I was pulling it off of a thing. So we'll do it live. And Homer with his can. Where's Homer at? Hold on. This Homer? Treeby, you got here right as we're getting done. We're almost done. Yeah, I don't even know. Oh, this one right here. that's I forget. That's not the one I wanted. Oh well, I don't know. All right, guys. I'm gonna go raid somebody. Let's go to end of stream here. If you guys got any questions, ask them down there. There's Paul Hartle. How you doing, man? You're up in Montana? What are you doing up there? That MT? Yeah. Not the mountains, right? This is MT Montana and MO Missouri. You're on vacation? Nice. The wife still has to go to Montana for one of her 50 states. My wife's trying to hit all 50 states before she turns 50, so there's that. All right. Let me go hit up. Let's go find somebody to raid over on the Twitch side. On the YouTube side, unfortunately, it'll just end. But we'll go find somebody. Let's see. Who am I following that's on? All right, we'll go hit up. We haven't went to this guy in a while, but he's pretty fun to watch. If you guys like technology generally. We're gonna go hit up Harold Pulcher. So we will we'll go raid him, and if you guys want, you know, give him the old. Oh, there's Paul with the Prime. Thanks for that, Paul. You guys can hit him with the raid message, which just hit him with the raid message. It'll be fine. People over on YouTube, come back, hang out, and all that kind of stuff. And Doc, I missed that, but I will. Let's see, what did Doc say? So much free stuff. Yeah. Go and do this stuff. Take care, everybody.